All right. How's everyone doing? Good? All right. So this is the first Unity workshop of spring of 2024. This one's going to be on unit testing and just test-driven development in general in Unity. It's pretty useful, and I hope you can learn a lot from it. So first off, let's go over some of the stuff. That's me. Jules isn't here today, so we're going to have Safine be teaching about 3D art in Blender, I think. Is it Blender? Blender, yeah. And make sure to follow our social media. If you're here, I'm guessing you probably have access to Discord, but if you don't, the link's right there. Make sure you join. And do make sure to join EGADS officially if you want a t-shirt. The t-shirts are pretty cool. I don't know if you saw in the Discord, there's a poll going around for the t-shirt design this year. Make sure to vote. I don't know if it's still open, but yeah, it closes today at midnight, so make sure to vote since you'll be the one wearing the t-shirt, right? And yeah, it's $10 to join, and you'll get pretty cool t-shirts. Every year, the design team does a fantastic job on the t-shirts, so make sure you get in on that. And make sure to join our GDC Squared. We do this every year. It's called GDC Squared because it's GDC, like Game Devs Conference, and then it's at the GDC, which is here. So it's GDC Squared. And this is Saturday, February 17th. It's 11 a.m. to 8 p.m. There will be food, and you'll be able to talk to some industry professionals, and it will be just a good event. So make sure to mark that down in your calendar, and make sure to sign up too. And special thanks to all of our sponsors. They make all of this possible, including these workshops. So thank you to them. All right, let's get started. So unit testing and game dev. So testing is a pretty important part of working on your games. So we should probably go into why we should test our programs. Whenever we're making something that's going to be used by chances are thousands of users. It is very important to make sure that our code is working. I don't know if anyone has ever run into bugs after they submitted something on their itch page for a game jam or something like that. It's never a good feeling. So it's a good idea, especially if you're working on something long term, to make sure you're running tests and making sure that everything's working as expected, especially if you're continuing to work on it in the future. So when you introduce new complexities to your code base, the stuff's still not breaking in your other parts of your code. So traditionally, when we're working on our games, traditionally when you're working on your games, when you test it, you really just hit play and then you just play your game. And then if you find a bug, you find a bug. If you don't, then it never existed, right? And this isn't the best approach. You end up with a time-consuming process. You have to hire play testers or ask your friends to play test your game for hours just to find small bugs. And then you have to find a way to log all these bugs, make sure you have a way for people to report what they find, and you have to go through each one and then manually solve them. So as you can probably guess, this is not the best way to test your code when you're working on a large project. It can take a lot of money for big projects to find all these little bugs. So this is why a lot of game engines or just coding applications will have some kind of automated testing. And this is a way for you to run multiple tests all together and write a bunch of tests that are separate from your code base, but make sure to test each bit of functionality and make sure everything's working okay. So this is an example of Unity's automated testing, and we'll go over that a bit. So what is a unit test? A unit test comes from the term a unit in a code base, which is like the smallest kind of bit of code inside your application. So for example, if you have one function that's adding or subtracting, then that will be the smallest unit. And then you would test that unit, and hence it's called a unit test. And you want these testable methods to be really small and locked down and isolated from the rest of your code to make sure that you're only really testing that one functionality. And we'll go over some examples of a unit test, but in general, you want to make sure that it's testing something specific and giving some kind of result and making sure everything's working normally without having other stuff interfere. And these can be added together to perform tests on larger game objects or larger parts of your code. So in the previous slide, you can see that there are a bunch of small tests that are all strung together to test that one bigger feature. Okay, so for an example, this is as simple as it gets for a C# kind of class with just two methods, an add and a subtract method. The add just adds the two numbers, and then the subtract just subtracts the two numbers. And if we were to implement a test on this, can you guys guess what you would probably test? Like if you're running some kind of test on these? Yeah. Yeah, definitely. I was going for even simpler, but that's definitely testing edge cases is definitely important for making sure that your methods are doing what you want, even if you're inputting something you might not necessarily want to put. But I was going for a little something simpler, just testing if the two things you're adding together are literally the correct result. So just kind of like grading a test. So for example, over here, you'll create an instance of your object, right? So that's the new keyword inside C#. So it was inside a class over here. So you would just create a new one, and then you would just call that method and then compare the result to like the real correct answer, right? So in this case, adding 10 and 10 will give you 20. And then you test that the result is equal to 20. And then that would just be a very simple test. But there is the principle of you want to test high numbers, low numbers, zeros, your ones, and making sure everything, locking down any kind of edge cases that might be in your code. But in this case, it's a pretty simple method. So you can just have a pretty simple result over here. Yeah, and the same thing for the subtract. You just check 10 minus 10 is 0. Oh, and this is all done using the NUnit framework. This is part of Microsoft's testing framework that Unity ends up using. And that's what's going to be integrating with our Unity tests. Okay, any questions so far? No? All right. So when you test in Unity, when you write these tests, it actually automatically syncs with Unity's UI using this test runner window. So you can see that we have our example math tests. That's our class that wraps around our example math. And you can see that our two tests over here are automatically shown. And these check marks are just basically, they did pass. So when I hit run over here, it just ran all the tests over here. It goes through each test inside the example math class, and then test add, and then test subtract, and then checks if these assert statements are correct. In this case, they are. So there's a check mark. If they don't pass, they do this this red circle X. Yeah. Okay. So first glance, this might seem really tedious. Like, this does add and subtract. It's not really. It seems a little verbose, right? But this does have certain benefits. Just having a habit of testing your code base. It leads to decreased maintenance costs. So when there are lots of methods, and maintaining a code base of that kind of size would tend to cost a lot of time and money just to make sure everything's working. And then also when you're adding new things, introducing new features, they're not interfering with what you wrote in the past and breaking those codes. And if they are, they will show up in that test runner, and then you would be able to spot it immediately before having to play your game and find out something else broke. It reduces uncertainty in this case too, because it's just, you can make sure that your certain test cases are passing and that everything's going okay. It also, yeah, in that case, helps detect unintentional changes, right? There are some drawbacks. The tests themselves may have bugs. Debugging a test seems a little counterintuitive, so you do have to make sure what you're testing for is your test implementations are actually correct and not buggy because that can lead to all sorts of problems. And also there's that increased initial investment that you have to start by writing the tests. But you can think of it as like a bit of an investment for the future, making sure later down the line you're not pulling your hair, trying to find out what's wrong with your code. So this leads us to a certain like philosophy in software development called test-driven development. So this is the idea where you're writing a test that fails at the start because you don't implement your code yet. And then you make the test pass by, I guess, I should use a white, but yeah. You're making the test pass by writing your code and then testing it and then testing your code against your test. So it's kind of like when you're writing LeetCode, when you're running your code with the test cases, making sure everything's working. And then you refactor to fix any of the mistakes that you have like one test case that's still not passing. And then you would go through that entire process. And this is essentially what test-driven development or TDD is. You're writing your tests, then your code, then you're designing your architecture around your code. It's a bit of a different inverted kind of way of coding, but it can have a lot of benefits. All right, so saying that, let's write a unit test in Unity. So we can go through, have a write one. So if you have Unity open, you don't have to open Unity if you don't want to. It's pretty simple. We're starting completely from an empty project. So you can just watch along if you want to. So essentially our entire testing part of our application is we're going to be using this test runner over here. I have it tabbed over here, but it's in Window General Test Runner over here. If you can't find stuff, you can also use the search button and search it. Yeah, I searched test earlier, it's right here. But yeah, it's Window General Test Runner. And what you can do here, this is going to be basically your testing platform where you're going to run all your tests. So we have this pretty handy tool that creates our little testing assembly definition. And if we just hit here, we'll create a folder called tests. It's fine. Yeah, we'll recompile. Yep. And what you can do is also create a test script inside that folder. So we'll just call it. But yeah, so now it creates this testing script over here. We can open it in Visual Studio for later. But yeah, so what it's going to do is create this little assembly definition in tests over here. And what an assembly definition is in Unity, it's literally just a dynamic linked library, which is going to essentially group all your code inside this one library over here. And because we don't really want our gameplay code or anything to be living with our tests in the same assembly, we'll probably create a new folder over here. And this is going to be for the game, right? And in there, we can create an assembly definition over here. We'll just call that game. Oh, oops. Yeah. But yeah, essentially, that was just partitioning your code base so that your gameplay code won't be able to access anything inside your tests over here. So we can go in test and we go in inspector. Right now, tests won't be able to see anything inside this game folder, right? Because it's in a separate assembly definition. You can think of it as like a package. So if you were to create a C# script over here, you would not be able to see it when you try to reference it in here. It's a bit complicated to think about, but it's a pretty good practice to separate parts of your code that doesn't need to touch each other. And because we do want our test to be able to access the game's code, but we don't want the game's code to touch the tests, we can create a reference over here and then just drag in. So now all our tests over here will have access to if we create a script over here, but not the other way. Okay, so now let's open that script over here that we opened a while ago. Yeah, okay, so this is going to be our basic layout for a unit test inside Unity. So Unity creates a pretty handy template for us. Up here, this is a test. This is just a normal NUnit framework test. And what this is going to do is just run simple functions, just like we did earlier with the math functions. And this is just going to run our tests. So we can throw an assert in here just to see. Assert is true. So if we pass in true, this is always going to pass. It's not a very useful test, but we can see it in our test runner now. Over here, you can see in our test, we have move tests, and then we have our two tests. We'll get into Unity tests. But if we were to run it, everything passes. It's all check marks, and we're all happy. So what we did there actually was just using a assert statement. We said, okay, we're going to test that true is true. And because of that, we pass, and the test case passes. Okay, so now let's get into Unity tests. Unity tests are, if you ever used a coroutine inside Unity, it works just like that, where you have something that's, you can skip frames and then just continue to run something that's going to run over some period of time. So that can be pretty useful, but for the most part, you'll want to use these simple tests because if you have a runtime for your tests, then you have to wait for that runtime to finish before you can continue and finish all your tests. So for example, if you have like a wait for 3 seconds in here, when you actually run all your tests, it's gonna run it all in series. So it'll run this, then it'll run this, wait the 3 seconds. Then if you have another test, it'll run further down. And those 3 seconds, if you have like multiple of them, they can really, really add up. So in general, you want to try to make it constant and make it really just run your tests with test. But we can do some examples of this. So if we have a game object, for example, so let's say we have our scene, right? We create a cube or something over here. We have a cube. We just make sure everything's okay. Yep. So we have a cube in our scene. What we can actually do is we can do GameObject.find cube. And then let's just assert that Go is not. Just comment this out. So when we do run this, we're gonna get one test case over here because we commented the other one out. When we run it, yeah, it's gonna pass. So that means it did find that one game object. Now, conventionally, you're not supposed to use GameObject.find because it actually, what it does is it goes through your entire scene and then looks for whatever game object's named is cube. Which isn't great if you're running it like every frame or something, but since we're only running these test cases once, that is perfectly acceptable. And there's nothing really wrong unless you have millions and millions of game objects. But in this case, we have 3, so doing this, it should be just fine. So then you can do stuff like you can use game objects transform, position, and stuff like that, and then you're all good. You could test stuff like that. Okay. For our Unity tests, let's just move test. You can do stuff with coroutines similarly, and you can actually, because it is a coroutine, you can use stuff involving time. So for example, you can reference this. We can target position. At 1. And then you can say while target position minus go.transform.position magnitude is greater than 0.0. So while it's still greater than maybe, then we can do alert. We should set a time. Go.transform.position equals vector3 lerp target position position and lerp time times time dot delta time. And then we can yield return null each time. And then at the end assert what we did here. Is less than. So what this is going to do is it's going to move. Actually, is this from A to B? I guess we'll see. It might be the other way around, but essentially it's going to move it and then test if it moved, essentially. And if we were to run the tests, it would actually move that one key. I did it right. Yeah, it did. What did I set the target to? Yeah, one, maybe. But yeah, essentially what it does is it moves it and then tests that it moves. So that's what you can kind of do with Unity tests over here. But in general, I do like using the regular tests. So this is pretty useful. It's pretty neat. You can test game objects that are inside your scene, but this isn't really that useful in the sense that a lot of times your game objects they're stored, right? You're serializing them as prefabs inside your code, inside your assets folder. So you can't really test them unless they're in the scene using this. So what we can do is we can actually test it as a prefab by instantiating. So let's create a folder called prefabs. And then we can drag this down over here. Let's just say, let's create a script, just a dummy script over here. Cube. So yeah, we have our basic void star and updates. This is just so we can remove that later. But essentially what we can do here is inside our tests, instead of finding cube, we can actually create one using assets load. So I believe it's game. We can do cube movement cube. So instead of doing this, we can do assets asset dot load. Oh yeah, it's asset database over here. Asset database dot load asset at tab. And then what we can give it is assets prefabs cube. And that's the file. And what else does it need? Oh, cube movement. Oh, we don't need to. That's an option. Oh, right. So you do need to give it a type. So now we have a reference to our cube. And then what we can do is cube movement cube equals prefab dot instantiate object dot instantiate. So what this does is it creates this little prefab over here. And essentially what it does is it does what we do when we drag our cube into a scene. So it creates a new cube over here. That's essentially what we just did over there. Now what we can do is we can just delete this cube from the scene. And when we run our tests over here, so run our tests, it should pass because it creates our cube over there. And then Unity's garbage collector will just destroy it when we test it. So, no. Cubes. Instantiating it. Which one is the cube? That's strange. It should be no. We do cube. I don't think it should be. I don't think it's actually no. Here. Anyway, regardless, we would be able to access cubes, transform and stuff like that. I don't know why the assert thinks it's null. But yeah, we can do an assert here over here. Let's just do a quick assert. So we can do our first test over here. So say an update over here, we will make the cube move, right? So transform position plus equals vector 3. Let's just move it up on X over here. So actually on the Z, and then 0.01. Move that. So when we run this over here, when we run our game itself, it should move. Delete it. Might be too slow. Oh, we didn't attach our script to our printout. Do that real quick. Cube, and let's drag our cube movement onto. So now we create our cube here. Now it should move. Yeah, it is moving. The camera angle. I'm put on the X actually. Yeah, it is. It is moving now. I'll increase it. But yeah, now that that moves, then we can test the movement of that cube in the test case. Yeah, it is moving. So over here, back to our test. So we can do assert is not true. We'll just do assert is true and then not. And then cube dot transform dot position. We'll just do not equals new vector 3 0 0 0. So what this is going to do is it's going to test if the cube is not at 0 after it moves. Actually, it won't move. It will actually over here actually fail because we don't actually call the update. So once it's doing this, it's not actually creating the object in the runtime because this is just a test. It's not using Unity's runtime test. So you can see that there is a play mode button over here in an edit mode. So the difference here is we're in edit mode. What all game engines have is they have a runtime, and when you create a game object, it uses the runtime to move stuff. So everything in our start and update over here is run inside the Unity runtime. So it goes through each game object and then runs this at the start when they're created, and then runs this every frame. This is different because we're actually in editor mode, so it actually doesn't know about any of Unity's basic functions. So we'll actually have to explicitly call it. The problem is The problem here is we don't really have access to these void update and void start because they're private. So what we actually need to do is do some kind of public void test runtime or something. And what that's going to do is what we can do with this is we can call the start method, and then we can call the update method. Or we can just call the update method in this case since we're not doing anything. But then what we can do here is we'll do q dot test runtime over here. And this cube is a cube movement over here. So that works. And then what this will do is it will run one frame of this update over here. So it would add 11 to 11 times the time the delta time. And then it would actually move. Maybe time the delta time. Oh, that's why you can't find the cube. I didn't put it's prefabs, not prefab. So because of that, it can't find the. So it shouldn't be this time the total. It shouldn't be difference. We'll run it again. This time it should pass because now it will be able to find. Yep. So now everything passes. It runs one instance of it. So that was the reason why it was null earlier. I just literally forgot the S. I named the folder prefab. But yeah, it couldn't find that prefab in the file path. So then I thought it would give an error here instead of error at the assert earlier. But yeah, so it couldn't find the file. But once it found the file, it could create the instance of that game object over here of that cube movement, and then run our update, start an update over here, one frame of that update over there. And then we test if that is 0, which it is not. So then it passes the test. So this is a way you can kind of test some of the movement inside your game objects and then test them as prefabs without them being in the scene. So in this case, we have a cube in the scene, but if this weren't in the scene, we can run this and it would still pass because it's creating it just for the scope of that test and then deleting it afterwards. So this is all good, but most of the time we're not just having our game objects move constantly in the update. We want like some kind of input, right? We want this to move if we press like D to move, and then you can move. I guess this is X, so positive X, I think, depending on our camera angle, but you would press a button and this will move. So we can do if input get key. This is the old input system. There is a new input system, but in this case, we'll just use this. So get key, and it would be key code dot. I think it was D. Or we'll just do space, and then that in there. So now let's just double check this. It should not move unless I press space. This is pretty basic Unity stuff, yeah. But our test cases will not pass because Now our update will run this and then check if the key code space is off. It is on and then do this, but it's not, we're not pressing our space key, so we won't be able to move. And because we won't be able to move, our position will be 0 because that's our starting position, and therefore it fails the test. So stuff like that you would be able to catch with a test, this move test over here. We can delete this. But yeah, stuff like this, you'll be able to test like, oh, you put it behind an input. If this were like a static move test to test if something were moving by itself, it would no longer work, it would break. So now that's no longer working. So we have to have a way of kind of like hacking our device to kind of fake that we're pressing this space key over here. So this isn't that easy to do because what this method over here is doing, it's a static method. It's trying to grab your get key over here and literally checking your hardware to see if you're pressing the space key and then doing it true. So there's no really real way to edit this over here, which is what our test case kind of wants to do. So what we can actually do, my notes over here. Yeah. So what we want to actually do is kind of wrap this into some kind of static method, and then kind of allow us to edit what we're getting from our return. So what we can do over here is we'll create a new little custom input or something, or game input. And what we can do is using so what we can do here is we can create actually there's a static class. And we'll just kind of pass through everything that we want from our input, our little input get key over here. So we can create a public static method called, we can also call this get key here, and it will take in key code over here. Oh yeah. Return so then we can he's complaining, but now when we call our I probably should generate the file from here. But yeah, so we can create this little game input over here. And now we can just call, instead of input.get key, game input. And now this always returns false right now. So what we kind of want to do is have this kind of, I think C# calls it delegates, but what you would do is essentially you want to be able to edit this, edit what this is pointing to. So right now we want it to point to, for our game's purposes, we want it to point to input.getKey, right? Get key. And our pass in our key, and then it will just behave the same as it was. So it would call this, which would pass it through, and then call input.getKey. And we want to be able to edit the definition of this. So this is a perfect use for delegates. So if we go to our tests over here, we want to kind of game input dot, we can create a we kind of want to create a pass through. So test key over here. Hi. And yeah, equals a little key over here. And pass through. This isn't defined yet, but then we want it to be key code space, right? So in this case, this is kind of weird syntax for C#, but in general, so we're going to create this. Actually, let's just create quick actions. So what this does is it creates this little function. It's a delegate that that is this test key over here, and then we want to set it to input dot get key over here. Equals key, and then pass it through over here. Object. See you. We want key code bool. And then yeah, so now that matches this the input. So it takes in a key and returns a bool over here. So now now what this does is it's still routing through input.getKey all the time, but what we can do here is we can pass it through test key over here. So it's kind of, I'll explain it a bit. Just this. So now we kind of like short circuited our little input.getKey. It's kind of weird, but what we're doing essentially here is we're calling our game input.getKey over here. So it's checking this against our this method. And this method is passing it through to this delegate. And a delegate is essentially a property that's also a method that you can redefine that method. It's a, I don't know if it's just a C# thing or if it's just an N. I don't know if other languages have that, but C# has this neat little way of creating a little method that you can set as a property and then redefine later on. So that's essentially what we're doing in our move test over here. So what we're doing here now is, I think this is easier to explain if it's over here. So essentially what we're doing is we're overriding what our game input is calling over here. So our game input is calling, okay, if you're pressing space, then we'll move. And then it's routing all the way through over here. And then eventually it's calling input.get. What we're doing in move test over here is setting this input.get key is always true over here. So now it would pass the test case. And then just as proper convention, we should probably set it back to input.get key. So now when this takes in a key, it will always return true. Then we'll test our cases. Then it will do this. So that it's running our update with assuming that we're pressing down the key. This is kind of faking our key input. And then we can do our assertion since our object already moved. It was already in the update. So now we run, these red X's should magically turn into green check. Yeah. Yeah. And this is better practice if we're testing a specific key. Right now, this is assuming anything are in our update method for any key is all true. So if we had this as like down arrow or something, this will still pass, even though we're trying to test for space. So what we can do is if we pass in a key, check if that key is, what did we say? Space? Space. Then now that shouldn't work because pressing down space is true, but we're looking for down arrow in our action. No, yeah, that's correct. But if now we go to our test and we're testing, well, actually, let's just say our test was looking for space because that's what we want. And someone went in our code and then changed it down arrow. Now it's not going to work. But if we say we want space over here, our space key is tested when we're testing our code. And then if we run, it's correct. And what it did is it just simulated that movement over here by running one update loop. Yeah, and that is essentially what I had for unit testing in Unity. This is a pretty easy way. You can do this with other systems too. The reason you kind of have to do this is a little messy, to have to bypass the Unity's custom input. The reason for that is because it's a static singleton that you can't really edit the output of stuff like getKey, but for stuff like getKey, you can't really edit that value. So that's why you have to go through all this rerouting. But for other systems, especially if you implement it yourself, you can implement a way to change those definitions for your testing purpose. But this is just an easy way to test movement and test your input and make sure everything's working okay in Unity. That's good. Any questions? I know it was kind of dense. Testing isn't the most wowing topic, but I think it's pretty cool and it's pretty useful when you're using Unity at companies. You have to do a lot of work with the test runner, a lot of work with writing unit tests and stringing them together as integration and system tests. All right, I think I can hand it over to Sophie. Should I stop the recording?
Yeah, you have to record.
Right now I'm recording. I can stop it though.